afternoon. Welcome to the case study discussion on noise reduction in aircraft, especially in Boeing 787, Dreamliner and Airbus A350. So today we are going to discuss how the vibration as well as the noise are produced in the aircraft and how this noise are giving a more disturbance and uncomfortable to the passenger. That will have the small discussion.
So, good afternoon everyone. My name is Katika from Third Aerospace. Now we are going to discuss what is the aircraft noise is because of engine airflow, landing gear and structural vibration. So during takeoff, the cabin noise is very much higher because the engine produces higher thrust, and during the cruise condition, the aerodynamic flow produces vibration. This also causes the noise in the cabin crew, and also in older aircraft, while the engines are it's not more advanced futuristic aircraft. So the vibration and noise is causing discomfort and communications problem. So this also causes stress and fatigue to the passenger present in the cabin. So therefore, aerospace engineers study cabin acoustics and vibration to improve the passenger comfort, safety and flight experience.
So this noise is not only because of vibration, based on our understanding. Vibration is different and noise is different. This is the acoustic materials that we can use to reduce the noise. So that is the one part. Now later we will discuss about that. So this noise is producing due to while takeoff, most of the turbulence are creating during the takeoff and the cruise condition. There the fluid structure interaction produce more turbulence. The more turbulence creation, more noise. So this creates the uncomfortability passenger. So your opinion?
Happy afternoon, I am Kavya from Third Year Aerospace. So let me tell how the materials plays major role in this noise reduction. For the noise reduction in cabin, most of the modern aircraft uses advanced composites, which are better than the traditional metallic materials. And for example, like aircraft Boeing 787 Dreamliner uses the large amount of carbon fiber reinforced plastic. So it also reduces the vibration better than the aluminium materials. So these materials will reduce the sound and decrease the vibration transfer into the aircraft body. So aircraft cabin also uses acoustic insulation panels and sound absorbing panels and vibration resistant floorings. This will reduce the engine and airflow noise. And this by using the composite materials, it doesn't only reduce the sound, but it also helps in the reduction of the aircraft weight. So it will improve the fuel efficiency and lowers the operational cost. So it also benefit for the passenger comfort and aircraft efficiency and performance.
Composite material usage is one of the main thing for reducing the structural vibration and the noise insulation. So one more thing is where the aircraft industry they are focusing on active vibration control materials. They are the piezoelectric patches. They are replacing they are combining with composite material. This piezoelectric material converting mechanical energy into the electrical energy, where the vibration is one of the mechanical energy. So with this piezoelectric patches, they are converting mechanical energy or the vibration or the structural induced vibration. They are converting this into electricity. These are one thing, the advanced material they are using here. So
one of the major advancement in the noise reduction is development of bypass ratio turbofans. So large quantity of air will be bypassed through the engine pole, and this reduces the exhaust velocity and also the lowering the noise level of the engine. So for that they will be using acoustic liners in engine nacelle, so which will reduce the sound wave that is created from the turbofans and the fan blades. So another technology used is serrated exhaust nozzle. So it is called chevrons, and this reduces the turbulence between the exhaust gas and the surrounding atmospheric air. So this will be minimizing the noises during the takeoff and the landing operation. So the aircraft such as the Boeing 787 Dreamliner uses the advancement technology extensively. So the international airports nowadays, the noise regulations are becoming strict. So the engine manufacturer continues developing the quieter propulsion system, reduce the environmental noise pollutions.
So now to explain about the propulsion, how propulsion creating the noises. Most of the modern aircraft they are using jet engines. Jet engines have the exhaust gases producing more thrust and more noise. Due to the exhaust gas, the mixing ratio with the atmosphere condition, it is getting delayed. That is how we are getting more smoke and more noise. So for that we are using one of the concepts bypass ratio. One more method is called chevron nozzle. By using chevron nozzle will extend. That means that sometimes based on the requirement, the nozzle exit diameter can changes the area, exit area. Like they can operate in different diameters in different conditions. So the critical expansion, under expansion, over expansion, these are major things happening in the nozzle. So over expansion creates more noise. So we have to maintain critical expansion of the exit of the nozzle. That's what this external bypass ratio, that is the atmosphere air, they are bypassing using the inlet curve, and with that bypass air is covering with the exhaust nozzle. So this is how the reduction of, that is mixture of fuel in the atmosphere is happening. It will not affect to the fuselage of the aircraft. It will act as a sound barrier. This exhaust bypass ratio will act as a sound barrier. So this is one thing, and chevron nozzle is that methodology they are using in the modern aircraft. Yes.
So good afternoon everyone. I'm Gopika from third year Aerospace department. So another important innovation in the modern aircraft is the active noise control technique. So this technique is used to reduce the noise inside the aircraft by using the microcontroller and speaker. So microcontroller detects the unwanted noise inside the aircraft, and the system produces the opposite sound waves that neglect the sounds. And AAU is very useful for low frequency engine noises and improving the passengers' comfort during long flight. And apart from the noise reduction, so vibration controls also plays a important role in the aircraft safety and durability. So engineers use the vibration isolators and damping material, flexible mounting system, and dumped mass damping to reduce the vibration which is generated by the turbulence and the engine operations. So in the future, the aircrafts are expected to use the advanced monitoring systems and special materials and the electric propulsion techniques. So these improvements can further reduce the cabin noise and make the passengers more comfortable.
So third part in reduction of noise in aircraft is active noise control materials. There they are using the feedback loop system, control loop system, where the sensor will measure the different noises and vibration. With that, it will produce the opposite signal, where the signal can counteract and it will reduce the amplification of or the frequency of the source vibration, like engine vibration or the fuel structure interaction. What is that? Induced vibration. It will act as counteract. It will act as a counterpart, and it will try to reduce the source vibration. And in future, they are focusing on intelligence material, that is smart material. It will absorb the vibration and will produce the electricity as well as the mechanical actuation. That is how the metal is going in future. Especially the monitoring system, AI-based monitoring system of capturing all the location like engine, fuselage, landing gear, wings, in all the areas. The sensor are monitoring the frequency, different frequencies like vibration. noise is acoustic. With this, the control loop system will evolve in future. We will try to reduce the maximum amount of noise, acoustic vibration and the structural vibration. This is how they are doing in Boeing 787 Dreamliner as well as the other aircraft industries. So this study helps us to understand how noise is one of the factors which affecting the passenger, and the source of noise which is connected with vibration of different components, and propulsion structures and active materials where the industry are using focusing on what are the possibilities to reduce this noise. This discussion is helpful to understand how the noise are based nature of the aircraft industry. Okay, thank you all.
Thank you.